Hello grade 10 and welcome back to the video tutorial for our subject Science 10. This is again Sir RJ Olarve, and for today we're just going to continue our discussion regarding laws of chemistry that govern the behavior of gases. So last time we are done with the first three laws of chemistry that govern the behavior of gases, which are the Boyle's law, Charles' law, and the Gay-Lussac's law. And for this video tutorial, we're just going to continue our discussion and we are going to tackle the combined gas laws, the Avogadro's law, and the ideal gas laws. So let us have now the fourth law of chemistry that govern the behavior of gases, which is the combined gas laws. So the reason why it is called combined gas laws because combined gas law is actually a combination of the three laws that we have tackled, such as the Boyle's law, Charles' law, and the Gay-Lussac's law. And this law states that the ratio of the product of the pressure and volume and the absolute temperature of a gas is equal to a constant. And another thing, when the Avogadro's law is added to the combined gas law, so we're going to have the ideal gas law, which will be tackled later. And this law is also stating that the volume of a gas is directly proportional to the absolute temperature, which is expressed in Kelvin, and inversely proportional to the pressure. So take note again of the word directly proportional. So again, when we say directly proportional, if one quantity will increase, the other quantity is going to increase also. So just like here, if the volume will increase, for sure the absolute temperature will also increase. But on the other hand, if one of this quantity will decrease, it is inversely proportional to the pressure, meaning the pressure is going to increase. And so we use the formula for the combined gas law, which is P1V1 over T1 is equal to P2V2 over T2, wherein P1 is the initial pressure, P2 is the final pressure, V1 is the initial volume, V2 is the final volume, and T1 is the initial temperature, and T2 is the final temperature. And in order for us to be familiarized with this formula, so let us have a word problem. So sample problem letter A. This is also found on your module and you are tasked to copy the solution that I'm going to present. So here we have the sample problem. A 40.0 liters balloon is filled with an air at sea level, which is 1 atmosphere at 25 degrees Celsius, and it is tied and thrown in a cold body of water, and it sinks to the point where the temperature is 4.0 degrees Celsius and the pressure is 11.0 atmosphere. And the question is, what will its new volume be? So the first thing you need to do is to analyze the given problem, and after you've analyzed the given problem, the next thing you need to do is to list down all the given values. So we have V1 is 40.0 liters, T1 is 25 degrees Celsius, which is P1 is 1.0 atmosphere, T2 is 4.0 degrees Celsius, P2 is 11.0 atmosphere, and then the unknown value is our final volume. And next is first again, and take note that in all the gas laws that govern the behavior of gases, the temperature must always be expressed into its absolute temperature, which is Kelvin. Okay, that's why. So our initial temperature, which is 25 degrees Celsius, will be converted into Kelvin, and also our final temperature, which is 4 degrees Celsius, must be always converted into Kelvin. So let's convert first our T1 and T2. So 25 degrees Celsius, okay, using our formula, K is equal to degrees Celsius plus 273. So you're just going to substitute your given degrees Celsius to this formula in order for you to get its absolute temperature. And moving forward, so substitute natin yung 25 degrees Celsius, just add 273. Same thing with this 4 degrees Celsius plus 273, and then we have our initial temperature 298 Kelvin, and our final temperature is 277 Kelvin. So just take note of the following given values because we're going to use this in our solution. So moving forward, so let's have the next step, which is our formula. So take note of this original formula, which is from this original formula, we're going to find the formula in finding our final volume, which is our V2. So from this original formula, we're going to have the cross multiplication of P1 V1 multiplied by T2, and we're going to have this P1 V1 T2, which is equal to the cross multiplication of the P2 V2 T1, which is here. And then afterwards, we're going to divide both sides by P2 T1 kasi dito sa right side natin ang kailangan lang maiwan is the V2. Kaya kailangan makancel natin si P2 at si T1 dito sa right side. And then, so dinivide natin both sides by P2 T1. Makakancel natin itong nasa right side na P2 at saka T1. Therefore, the formula that we're going to use in finding our final volume is P1 multiplied by V2 multiplied by T2 is over P2 T1. And take note of this formula because we're going to use this on our solution. So here is our solution. So you're just going to substitute the given values na nilistaw natin kanina doon sa first stage, which is the listing down of our given. So what is our P1? So we have 1 atmosphere. Our V1 is 40.0 liters. Our T2 is 277 Kelvin. Our P2 is 11 atmosphere and our T1 is 298 Kelvin. And then perform the indicated operation. So dito muna tayo sa taas. Okay, sa numerator, so we have 1 multiplied by 40 multiplied by 277. This will give you the product 11,080 atmosphere liters Kelvin. And then sa ating denominator, so it will give you the product 3,278 atmosphere Kelvin. And then here, makikita nyo kinansel natin yung magkatulad ni unit, which is yung atmosphere and Kelvin. And then performed or divide this 11,080 to this 3,278, which will give you the answer for our final volume, which is equal to 3.38 liters. So therefore, the new volume is 3.38 liters. Next, we have the Avogadro's law. So Avogadro's law, in the year 1811, an Italian scientist, Amedeo Avogadro, interpreted Gay-Lussac's findings and formulated his own version of the Avogadro's law, wherein this law states that the volume of the gas is directly proportional to the amount of substance of the given gas. And then this is also known as the volume is to amount of substance relationship. And then here in this Avogadro's law, we're going to use the formula V1 over N1, which is our amount of substance 1, which is equal to our V2 over N2, wherein V1 is our initial volume, N1 is our initial amount of substance, V2 is our final volume, and our N2 is the final amount of substance, which is our amount of substance is expressed in mole or MOL. And then we have our sample problem. In order for us to familiarize with the formula, V1 over N1 is equal to V2 over N2. So we have this sample problem wherein if 0.00810 mole neon gas at a particular temperature and pressure occupies a volume of 214 milliliters, what volume would 0.00684 mole neon gas occupy under the same conditions? So take note that the temperature and pressure in this law is said to be in the same condition, so constant. Okay, so after you've analyzed the given problem, so the first thing you need to do is to list down all the given, wherein our N1 is 0.00810 mole, our V1 is 214 milliliters, our N2 is 0.00684 mole, and our unknown quantity is our final volume or our V2. Okay, and going back to the discussion about this Avogadro's law, so we use the formula V1 over N1 is equal to V2 over N2, and from this original formula, we're going to have our formula in finding our final volume, which is this. Okay, so same thing, so just cross multiply. We have N2 V1 and then cross multiply our N1 V2. So kahit alin ang mauna dyan, kahit V1 or N2, basta ito yung makasama sa left side at sa right side nyo. And then again, so the formula that we need to have is the formula in finding our V2. Okay, kaya naman dito sa ating right side, kailangan makancel natin itong si N1. That's why you're going to divide both sides to N1. Alright, so after nating ma-divide both sides by N1, so cancel si N1, and then we're going to have our formula V2 is equal to N2 V1 over N1. And take note of this given and formula because we're going to use this in our solution. So for our solution, we have our formula V2 is equal to N2 V1 over N1, and then next step is to substitute the given values for our N2 V1 and N1, which are our N2 is 0.00684 mole multiplied by our V1, which is 214 milliliters over 0.00810 mole. Okay, so perform natin yung indicated operation. So let's have first the numerator, which is 0.00684 mole multiplied by 214 will give you the answer 1.46376 mole, that milliliters, and then divide it to 0.00810 mole. Cancel natin yung mole, and then it will give you the answer for our final volume, which is 180.71 milliliters. So therefore, at the same condition, so same temperature and pressure, so the volume that 0.00684 mole neon gas will occupy is 180.71 milliliters. And that's our sample problem under the Avogadro's law. And we are down now to our last law, which is the ideal gas laws. Okay, here, the ideal gas law was actually discovered by the physicist and engineer Benoit Paul Emile Clapeyron in the year 1834, wherein this law states that the volume of a gas varies directly with the number of its molecules and absolute temperature. Volume also varies inversely with pressure. And then we use the formula wherein PV is equal to nRT, where our P is the pressure, which must be expressed in atmosphere, volume, which must be expressed in liters, N, or our amount of substance, which must be expressed in mole, and our ideal gas constant, which is represented by uppercase letter R, with the value of 0.0821 liters per atmosphere over mole per Kelvin, and our temperature, which must be always expressed into its absolute temperature, which is Kelvin. So take note, yung pressure natin, bakit kailangan yung atmosphere? Kasi nakikita nyo dito sa gas constant natin na ang ating denominator ay naka-express, or ating numerator is na-express sa atmosphere, para makancel natin yan doon sa ating formula. So same thing with our volume. Ito, para makancel natin yung liters dito, kailangan yung volume mo muna ay naka-express sa liters. And the same thing with our temperature, Kelvin, para makancel natin itong nandito sa formula or unit ng ating ideal gas constant. And in order for you to familiarize yourself with this PV and RT formula, so let's have our sample problem number 1 on your module. Again, this is sample problem number 1, not letter A. So here, what is the pressure in atmosphere of a 0.108 mole sample of the gas at a temperature of 20 degrees Celsius if its volume is 0.505 liters? So after you've analyzed the sample problem, so first thing you need to do again is to list down all the given values. So let's have our V, which is our volume, is equal to 0.505 liters. So no need to convert it to milliliters because again, our volume must be expressed in liters. And next, um, given is our temperature, which is 20 degrees Celsius. So Celsius must be converted into Kelvin. So that's why you need to add 273 into this degree Celsius. And then 20 plus 273 will give you 293 unit is Kelvin. And the amount of substance is equal to 0.108 mole. And also we have our ideal gas constant. So kahit di siya nakastate dito sa ating sample problem, still kailangan nyo parang i-include yun sa ating given, which is equal to 0.0821 liters atmosphere over mole Kelvin. And our unknown quantity is our pressure. And recall, so we use the formula PV and RT. And from this formula, so we need to derive our formula in finding our pressure. So, paano gagawin natin dyan? So, just divide both sides by V or volume para makancel natin yung V dito sa left side and then maiiwan lang IC pressure. Okay, so cancel yung ating volume and therefore, so the formula for our pressure is equal to nRT over V. And then for our solution, so just substitute the given for our N, RT, and V. So we have our N is 0.108 mole. Our ideal gas constant is 0.0821 liters atmosphere over mole per Kelvin multiplied by our temperature, which is 293 Kelvin over 0.505 liters. So ito yung sinasabi ko kanina, bakit kailangan naka-express etong si volume natin kay liters para makancel natin yung liters na nandito sa ating formula. Kasi kung milliliters to, hindi mo makakancel yung formula na yan. And same thing with our Kelvin, kaya kailangan naka-Kelvin yung ating temperature para makancel natin itong Kelvin na nandito. And also here, so kaya kailangan atmosphere kasi ngayon yung nire-require nitong ideal gas constant na formula or unit para sa ating pressure. And then perform the indicated operations. So we're going to multiply all these values found on your numerator, which will give you the product 2.5979724 atmosphere kasi kinancelan natin dito. Okay, dito sa taas yung mga unit na yun. So imagine nyo na nakancel ko na dyan. Okay, and then divided by 0.505 and then it will give you our pressure value, which is equal to 5.14 atmosphere. And that is our sample problem under the ideal gas laws. So that ends our discussion about the different laws of chemistry that govern the behavior of gases. And again, we have actually 6 laws of chemistry that govern the behavior of gases, which are the Boyle's law, Charles' law, Gay-Lussac's law, combined gas law, Avogadro's law, and lastly is the ideal gas law. And if there are things that are unclear to you, so don't hesitate to contact me at any of this contact information that you can see on your screen. And as a reminder again from 1 Corinthians 10 verse 31, so when you eat or drink or do anything else, always do it to honor God. So God bless grade 10 students. So see you on our Zoom meeting this week.